Hello everybody, this video is going to be for 5.5. We are not going to be sketching a graph of an arithmetic combination of two functions, so let's go ahead and just get rid of that. We are not looking at this from a graphical perspective, but what we are going to do is we are going to do the arithmetic combination of two functions. Okay, if you're not sure what that means we're going to add two things together, subtract two things together, multiply two things together, and divide by two things together. And we also are going to ask you to look at the domains for each one of these, which we can verify with the calculator. So let's go ahead and take care of these problems. I have 5 problems lined up for you, and let's go and get going to it. This notation, so I just want you to be aware that whenever you see this notation, it says f plus g of x, I want you to just think as this is just add. Just add what you have. So we're going to add these two parts together. We're going to add 3 root x and negative 10 root x together. So 3 root x plus negative 10 root x. And you might be thinking, well, that was silly of you to write negative plus a minus, because, I mean, that's just minus. So now it's going to be 3 root x, and again, a plus and minus is just a minus 10. So minus 10 root x. And what I do here, in case you're not certain, because some people were a little uncertain of it the last time that I showed them this, is I'm just going to subtract those two numbers together. So 3 minus 10 is going to be a negative 7 root x. And that's it. So that's the first part. It says find f plus g of x. That told us to add those two things together. In this case, we ended up subtracting them. Same thing, same difference. And when we added them together, we got this. Now, it does say state the domain, so we'll deal with that later. But so state the domain we'll deal with later. But for evaluating the sum when n equals 4, basically what that means is once you're done and you got your answer, plug in 4. So now when x equals 4, we get negative 7 times the square root of 4, which is negative 7 times 2, because the square root of 4 is 2. That's negative 14. For each one of these problems, I'm going to come back to the domain in a minute. I will not do the domain right away. So let's go to example 2, because I just want to get the general idea down. This one says to subtract. So it gives us these two things here, f of x and g of x. It says find f minus g of x and state the domain. And then evaluate the difference when x equals negative 2. So again, whenever you see this, this is a very, very fancy way of just saying subtract the two things that you see. So we are going to subtract this part and that part together. So let's go and do it. We got 3x cubed minus 2x squared plus 5. And we are going to subtract from it, actually I don't need those parentheses. We are going to subtract from it the second part of it. So we are going to subtract x cubed. We are going to subtract negative 3x squared, which is a positive 3x squared. We are going to subtract 4x, and we're going to subtract a positive 4x, which gets a negative 4x. And we're going to subtract a negative 2, and that's a positive 2. All right. One thing that I do want to clear up here is when I did this part, I basically changed all the signs. This was an Algebra 1 thing that you saw. You change all the signs when you're subtracting. So I put a subtraction x cubed, a plus, I did a minus and a plus. Okay, so when I subtract something, I change all the signs on the second part. So now let's go and combine like terms here. When I combine like terms, I'm just going to color code this here. I'm looking for 3x cubed and negative x cubed, negative 1x cubed. So 3x cubed minus 1x cubed is 2x cubed. Next, I got a negative 2x squared and a positive 3x squared. And sometimes students write this out on the side, and that's fine if you do that. That's going to get a plus 1x squared. Let's go ahead and do x's. Negative 4x. No other x's by themselves, so it's just a minus 4x. And then a 2 and a 5. Let's do a 2 and a 5, 2 and a 5. It's going to be a positive 7. That's my answer. So that's going to be f minus g. Now, again, we're not doing the domain yet. So no domain just yet. We'll hold off on that part. So hold off. To evaluate. Evaluate is a very, very fancy way of just saying plug in. So plug in -2 now. So plug in -2, and we got 2 times, in parentheses when you enter your calculator, 2 cubed plus 1 times -2 squared minus 4 times -2 plus 7. Okay, I'm going to assume that you're using your calculator for this, and I'm going to use my head for the calculator. Doop 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 doop. 19, and I got 3. If I'm wrong, tell me in class, but I got 3. All right, guys, let's go into the next one. And again, we will come back to the domain at the end of the video. Let's do 3. Now we got to multiply them. Whenever you see FG like this means F and G in parentheses with no addition subtraction means multiply them. This one's going to be easier. So what we're going to do is we're going to multiply the x squared and the root x together. X squared times the square root of x. Guess what? That's just x squared times the square root of x. Now there is one other thing you could do to it. I'm not going to tell you what that is because it's not worth our time. So that's all for the times. That was an easier one. Let's go and do the evaluate. Remember, evaluate again, it means just plug in a 9 to your answer. So we're going to get when x equals 9, we'll get 9 squared times the square root of 9. Now 9 squared is 81 times the square root of 9, which is 3. And I could get my handy dandy calculator out and I would find out that this answer would be 243. Okay, now again, one thing that I didn't say right now is to state the domain, and we will talk about the domain afterward. Let's go on to 4. For 4, we got 6x and x to the 3/4. So let's go and look at this one. Here we have f over g. F over g is going to be, anytime you see this fancy thing, this just means divide. Now with the x, I didn't say this in the other 4, on the other 3 examples, even with this x on the outside, it still just means divide. There's all a very fancy way of just saying, please divide the 2 functions together, which means I'm going to take 6x and x to the 3/4. I'm going to divide them. And there they are divided. Now, if you're good with your properties of exponents, or if you like to challenge yourself with the properties of exponents, we could actually take these two and clean these up a little bit with an x to the 1 minus 3/4. Because remember, when we have the same base, and by the way, there was a 1 here, that's where that 1 came from. When there's the same base, you can subtract the exponents. When there's the same base and you're dividing, right? So if it's a base to a number and another base, same base to another number, you can rewrite that as a base to the number minus the number. When we do 1 minus 3/4, again, if you feel like this is, you want to challenge yourselves on this, please do. You can end up getting x to the 1/4. Because the 1 is the 4 over the 4, right? 1 over 1 multiplied by 4 on top and bottom is 4 over 4. Minus 3 over 4 is 1 over 4. Okay, if all that stuff makes sense, we could rewrite our answer as 6x to the 1/4. It's totally up to you on how you want to do that. I won't take points off either way. Finally, let's go and get our final answer here. So now we're going to plug in, I'm not looking at the domain yet, we're going to plug in x equals 16. So when we plug in x equals 16, we're going to need 6 times 16 to the 1/4. If you did that way, if you did the other way, and you don't want to do simplify, you got 6 times 16 over 16 to the 3/4. Either answer is going to get you where you need to be. For the left, we need 16 to the 1/4, and I'm in my powerful numbers booklet, and I saw that 16 is equal to 2 times 2 times 2 times 2. And this little one tells me I need one of those, so this part just becomes a 2 and a 6, and I get 12 when I multiply them together. On the other side, 6 times 16 on the top, that's 96. And now I need 16 to the 3/4. So remember, 16 is equal to 2 times 2 times 2 times 2. And I need 3 of those. And that's going to be, I believe, 8. So it's going to be 96 divided by 8, which is also 12. Either way would be fine. Totally on you how you want to do that, but that's how you evaluate again. We'll look at domain afterwards at the end. Okay, finally, f plus g of 2. Well, f plus g of 2, so what this means is you are looking for y values, so let's just write this out. Look for the y values at each x value. So let me just do value at each x and subtract. Okay, so that's what you're doing here. I'm just going to so this fancy way says x equals 2. Over here is x equals 3. Over here is x equals negative 1. And over here is x equals 0. So let's start with the first one. Let's start with x equals 2. So when x equals 2, I'm only looking for these two numbers. Here's f and here's g. Okay, when x equals 2, I need to add the two y values together. So when x equals 2, I want to add these two y values together. So I'm adding 4 plus negative 4, and I get 0. This is f plus g of 2. And I'll repeat this process each time with the 3 now. So now when x equals 3, okay, when x equals 3, I am looking solely at the row where x equals 3. Okay, so when x equals 3, I have these two values here, negative 2.5, and I'm told to subtract them. So do negative 2 minus 1/2, or minus 0.5. I'll change that back to a 0.5 here in a second. Okay, negative 2 minus 0.5, I believe, is negative 2.5. That's all for that one. Let's go to the next one. X equals negative 1. So for x equals negative 1, here's x equals negative 1 because x is negative 1. And now I'm just looking at these two values, 3 and negative 5. And that sign in between them is multiplying, so let's multiply them. So fg of negative 1 equals 3 times negative 5, and that is negative 15. And then finally, I think we have f divided by g of 0. Let's do that one. F divided by g of 0 is when x equals 0. Look at these two numbers, 2 and 1, which means I have to do 2 over 1, which is 2. And this is f over g of 0. So again, notice that this is not saying to multiply everything by 0. It's saying when x equals 0, divide those two numbers. Please note it may not always be f of g. So for instance, if you had g over f, it may not be f over g, it may be g over f. If you had g over f just as a different problem of 0, you would still be looking at these two numbers at 2 and 1 when x equals 0. But g would be first on top, so this one would be 1 over 2. I just brought up that extra problem just so you're aware that the order does matter here. And we're not just putting one number over the other blindly. All right, now we need to go back to the domain for each one of these. What I'm going to recommend for these is knowing your domains for all of these. So here's what I'm going to say. Your domain, and then I'm done. Your domain for any polynomial, which is like x to a number, is always going to be all reals. Your domain for a root, just a square root, is going to be is going to be 0 to infinity, and it won't change from that. If you have a cube root of x, your domain is all reals, and I'm going to just do one more for you, and then I think that's it. Let's go and go back here. Let's go and just select all this and move this over here. Okay, and your domain for the fourth root, because I think I saw one on there, is going to be 0 to infinity. Okay, so now let's see what we have here for our domain. Here we have a root. So because we have a root, just copying this down again, we get 0 to infinity. So that's what our domain is, 0 to infinity. Let's go to the next one for example 2. Example 2, this is a polynomial because it's just nice powers and they don't have any roots. No roots, polynomial. So that domain is going to be all reals. For this one, we end up having a root. We have a root right there. So that's going to be 0 to infinity. And I'm assuming you jotted these down so that way you can see them. I'll go back to the page at the end. And then for number 4, you'll notice that we have a fourth root. And anytime we have a fourth root, we're going to have to do 0 to infinity. Okay, so those are your domains. Hopefully that was helpful. And here's your domains. Thanks for watching, guys.